Everything has an end, even the infinite universe. In this moment while we are speaking, hundreds and thousands of stars, planets, and black holes are forming across the universe. Meanwhile, the universe itself is expanding faster than the speed of light, causing the galaxies to move away from each other. Obviously, this greatness and beauty had a beginning, and this beginning is called the Big Bang, which occurred in only a fraction of a second. Time started since that event, which it brings us a question. If time started somewhere, will it end somewhere else? The universe is not a specific body, and it's actually a combination and collection of galaxies and stars together. So how will the universe end with that? Or in short, what are the possible ways for the universe to end? Well, we'll talk about it now. Today, we'll be talking only about the most theorized method by scientists that are nominated to be the end of the universe. Before we talk about it, let us clarify an important point on this subject. The future of the universe depends greatly on its expansion velocity, and the level of expansion accelerated by a mysterious energy that makes up 68% of the universe, and scientists call it the dark energy. Dark energy only causes the acceleration that occurs to the expansion of the universe, and not the expansion itself. Nobody knows yet what is the main cause for the expansion, but what we do know is that dark energy is defined in the property of empty space in the universe. In other words, the more space we have, the more dark energy we'll get. As a result, expansion accelerates more and we'll have more space. However, scientists are still investigating and researching about whether the total dark energy equals its density in the universe. In fact, the idea of cosmic expansion has been simplified by an equation called Friedmann Equation. Friedmann Equation describes the complexity of dark energy and expansion. In Friedmann Equation, we see the letter A here, which describes for us the relative size of the universe. As the universe expands, A expands too. The letter A that has 2 points above it is called double dot notation, which is often used to describe second derivative of a function. In the equation, double dot A represents the second derivative of the scale factor with respect of time. The scale factor is a measure of the size of the universe. Beside that, it'll also describe to us by the level of cosmic expansion whether it's accelerating or deaccelerating. If the mass level of objects in the universe is low, their gravity will not affect the force of expansion, and the universe expansion will continue. And if the gravitational forces of the cosmic objects are high, the level of acceleration will slow down and the universe will shrink. This unit is the density of the universe, which includes the energy density of matter, radiation, and dark energy. The positive sign before pressure can also be negative or zero depending on the nature of the matter and energy content. The negative sign describes the deceleration or negative expansion of a universe dominated by matter. Meanwhile, the positive sign describes the accelerating expansion of the universe, implying for the pressure to act like a repulsive force pushing matter apart. There are 3 types of expansions. First one, -1/3 more than W. The total and density of dark energy will be equal in magnitude, which will slow down the expansion of the universe. The second one, or W, is equal to -1, which could be our universe. The total dark energy is slightly less than its density level at first, but after billions of years, the total dark energy will increase significantly at the level of its density, and this causes an extraordinary acceleration of the universe. However, this will not cause eternal acceleration, and the expansion velocity will return to normal. The last one, or -1, is more than W more than -1/3, the total dark energy will increase in a sudden high speed, causing eternal and rapid expansion. What the letter W means in the digital illustration is a mathematical unit subordinate to the state equation, in which the pressure is divided by the density. After this long clarification, we can now start with our topic. Well, there's an overall expansion which is called -1/3 more than W more than -1, which the total of dark energy is way more its density. This type of expansion will cause a great condition called the Big Rip. In this type, the universe will expand so large that the force of gravity will not resist the expansion, and the universe will expand to the point that the event horizon of the universe will expand at an extraordinary level. And at first, the event horizon will become small relative to the Milky Way, then it will get smaller and smaller to the size of the planet Earth, and this process will continue until it becomes the size of atoms. And finally, it will destroy the small structure of the atoms and leaving only subatomic particles that will not combine with each other due to the large space. This process is one of the most frightening ways of the universe to end. The second type, the Big Crunch and the Big Bounce. The Big Crunch shows us the first type of expansion, in which the force of expansion is affected by the attractiveness of cosmic bodies, which slows the acceleration and shrinks the universe. When shrinking, objects and substance will gather the universe at one point, causing another Big Bang. When the Big Bang happens, in the normal case, a second universe will be formed, and the same process will be repeated forever, and this is known as the Big Bounce. The Big Crunch is the process of dying, and the Big Bounce is the cycle of death that occurs in the different universes. The third death is called the Big Freeze. Simply in this type, the universe will normally start expanding after the Big Bang, and the universe expansion will be fast enough yet slow enough for the objects of the universe to not be destroyed or cause another Big Bang. But a day will come that all types of stars and black holes will lose their fuels, leaving no heat and energy in the universe, leaving eventually nothing but a cold and dark universe behind them. We wouldn't have understood these methods and processes without our explanation of the dark energy mechanism and the types of expansions. You don't have to worry for these methods to happen to you, because they will not start until after billions of years. But here comes a question. If the Big Bounce is infinite, then where was its beginning? Well, we'll leave this topic for another day. But until that day, do not stop wondering and be curious.